first comment, if you guys can, if you have your homework out, I'd like you guys to just jot these little bits of information down as you go. And I noticed that when third period turned in their assignment, I saw some of them comment on certain best practices here. First of all, it was Sophia in the previous period. I think she's not in this period, but she, as she was going through the problems, she would write me a question like, do I do direct substitution at this point? So ... She would ask me the question, and then as I'm grading it, I can answer that question in the comments. I like that because then I know, especially if I'm checking homework, that's the beauty of online, is that I can check some of the homeworks ahead of time so that I can see what questions the class is really struggling on, and then I can answer the questions that way. So if you guys do have a question, I encourage you guys to like jot on it, no judgment. I would rather have you guys ask me questions than and me address it before it becomes an issue later on. So that's one comment. The other comment is, if you can write this down, is that AP standards for rounding is, so what I saw with number 6 was that we plugged it in negative pi quantity squared minus 7, and some of you guys punched that into the calculator and gotten a decimal approximation. I'm going to say that if the directions don't say it, that you just leave your answer in what we call calculator ready form, which is, that's my final answer. We're not going to round because this is exact, and this is going to be a big theme as we go through. However, if it does say round, it will not tell you on the AP test what to round out to. So if your answer happens to be 5.21, and this is not the answer, but I'm just making it up here. Let's say you punch that into the calculator and you get 5.2187. You guys are going to round to 3 decimal places, which to 3 decimal places would be 5.219, or you're going to do what is allowed as well, called truncating. And truncating is cutting off after the third significant form. So in this case, 5.218 is also acceptable. So either one of these would be acceptable. So rounding or truncating is okay to do if the directions tell you guys you have to provide a decimal approximation. Otherwise, leave it in calculator ready form. So that would have been the final answer. That's going to be increasingly important as we go through free response questions, especially if we're not in the calculator section. Now going down to these questions, first of all, I'm so impressed that so many of you guys were able to figure out questions like 23, asking you guys to do things like, okay, what does it mean, don't rationalize factor? I think this was just encouraging you guys to think of this in a different light. So I'd like you guys to have your chat window open and feel free to chat at answers to questions as we're moving through lessons and homework. But when you guys are factoring x minus 9, x plus 9 differences of squares, all over 3 minus square root of x, you might be thinking, well, how else can I factor this? Well, we've never done this before in previous classes, but if you look at x minus 9, this is also a difference of squares. So we could also factor that to be something times something is x. What times what is x? And feel free to type in the chat or say it out loud even. Let me open up my chat window.
Square root of x.
Excellent. Square root of x, square root of x, and let me open my chat window here. Okay, square root of x and square root of x. And then what times itself is minus 9. Good, 3 and 3. So sorry, I'm writing so messy here. So when we look at that, I saw some of you guys start to do things like cancel. You got this far. You started canceling this and this, which is great, except for that the signs are opposite of what we want. So what we actually should be doing is taking out a negative, factoring out a negative from one of these terms. So this is really negative 3 minus square root of x, if I reverse the signs of what was inside before. And now I can cancel with the bottom right there because it's the same sign. And so some of you guys had positive 108, so the answer was negative 108. So after that, after you guys simplify algebraically, you do direct substitution again, you get negative 108 as your answer. 24, so this I'll do briefly. If at any point you guys have questions on like algebra 2 trig stuff, pre-calc honor stuff, that's a great, that's when the tutorials would be a great time for me to review things like factoring with you, to review more on what synthetic division, for example. Some of you guys saw this and you remembered, I even saw plus or minus p's over q's, which I know is like, it was not a fun part, at least for me, in pre-calc honors and in algebra 2 trig. But if you plug 2 in initially, you do direct substitution, you notice that you get 0 on top and 0 on the bottom. I saw someone write indeterminate, which that is the correct phrase for it. And we'll talk about how we could do this when it's indeterminate when we cover L'Hopital's rule later on, which will be nice. But right now, algebraically speaking, if I plug 2 into something and I get 0, then that tells me that 2 is a factor. And that 2 is a 0 of that function, that was the remainder theorem. And from there, if I want to know how many times does x minus 2 go into x to the 5th minus 32, we can do something called long division, or we could do something called synthetic division. Can you guys let me know, do you guys remember synthetic division in the chat? Yes or no? Okay, good. And synthetic division simply said you have 1 is the first coefficient, and then since this is x to the 5th, you need placeholders, x to the 4th, x cubed, x squared, x, and then negative 32. And from there, you bring down the 1. So 2 times 1 is 2, add. Again, great time would be during tutorial if I'm like, Mrs. Kim is going so fast. 2 times 16 is positive 32. We have a remainder of 0. So from there, x minus 2 went as a factor. So I factored x to the 5th minus 32 to be x minus 2 times the leftover equation. Since we divided an x into x to the 5th, this is now x to the 4th. So x to the 4th plus coefficient being 2 next, x cubed, plus 4x squared, plus 8x, and then plus 16. And that's all over x minus 2. And voila, your x minus 2 cancels out. And now you guys can do direct substitution into that term above, polynomial above, and then you guys will get 80 as an answer. The people who said kinda and a little bit, was that enough information for you guys to remember synthetic division? Okay, good. And if it's not, please feel free again to sign up for tutorial. We can go over it together. But that's what you'll notice for the first few weeks. It's just like, if you need more, you guys come see me for tutorial. There's no shame in that. Okay, so the next part of, I'm gonna spend about 3 minutes with you guys on 3 reasons why limits do not exist. And then I'm going to transition you guys to a break room. So if I can have you guys take out a sheet of paper for me, or open up your notebook. Let me add paper here. Okay. All right, so we'll say there's 3 ways that limits do not exist. So limits do not exist when okay, so you guys have already explored, and I saw some of the reasonings for piecewise functions on one of the videos that you guys did on why limits don't exist. But can someone tell me what's one way limits do not exist? How do I know when it's D and E?
When the left side limit doesn't match the right side limit.
Yes. Okay, so when the left-hand limit does not match the right-hand limit. You guys, when I write these reasons out, when you recorded notes on continuity tonight and they give you guys those reasons, those are official reasons. So I want you guys as much as possible to write things like in notation the way that I just did. And the clear example of it is the step functions that we covered in a video. Okay, the greatest integer function. If I come at it from the right, this is called the right-hand limit, it's approaching 1. If I come at it from the left, it's approaching 0. So these limits do not match, and it's the intended height, so it doesn't, oh, Alex, are you having trouble with something? And Ed? Okay, so the left and the right-hand limit do not match, so then therefore the limit does not exist. So we're going to write for this one, that's the first reason why it does not work. Okay, so the second reason why a limit might not exist is f of x increases or decreases without bound. And when we start talking about without bounds, that's going to be infinity. And so our latter portion of the period, we're going to talk about infinite limits or limits with infinity and at infinity. So those are the cases where you guys see rational functions that look like this. You guys, what is this called right here? What's that called? This line that I'm tracing right here. Very good, a vertical asymptote. So as you guys approach it from the right-hand side, it's going to positive infinity. As you approach it from the left-hand side, it's going to negative infinity. So this is increases and decreases without bound. So we would say it does not exist because one's going to positive infinity, the other one's going to negative infinity. If they both went to positive infinity, like the top portion right there, then we would say that although it does not exist, we can qualify it by saying it does not exist because it goes to positive infinity. Or if both of them head down to negative infinity, we can say negative infinity. I can tell you guys, I'll give you guys hints throughout the, as we do notes and stuff, but like on one of your questions on your test later on, it might be multiple choice and it might say, why does the limit does not exist? Or what is the limit? And you might have to say it's either positive infinity or negative infinity or does not exist. If they, again, I'll repeat, if they go in opposite directions from the left and the right, it does not exist. But if they both go towards positive infinity on the left and the right, then we would say that it's positive infinity. If it's both going towards down to negative infinity, we would say it's negative infinity. Pause, questions, anyone in the chat about that or out loud? Okay, then the third reason is graphically speaking, if we can't pinpoint a value that it tends to, then it's bouncing back and forth. It's oscillating between two fixed values. And it's not actually headed towards anything. So as x approaches c, we're noticing it's bouncing back and forth between, let's say, the y-axis, or sorry, the x-axis. So an example of that, if you actually graphed limit as x approaches 0 of sine of 1 over x, what you would see graphically on your graphing calculator is, let's say you're approaching 0 and that's not what I intended for it to do. You're approaching 0, but then as you approach 0, it's going back and forth like that. And it's bouncing back up and down between two numbers, and it's not really tending towards the same number or a common number like it would in a limit where it exists at 0. So we would say that this also does not exist. That one is not as common as the first two for us to examine, but that it would be a third reason why a limit doesn't exist. Okay, you guys, so I'm going to now experiment with breakout rooms a little bit. I'm going to stop sharing my screen here. And when I hit breakout room, it's going to divide you guys into